In this video, we're taking a look at some problems where we're translating between equations, tables, and graphs. A familiar concept, but still worth taking a look at and remembering how we can approach these. So for this first one, we're given the equation up here, but we're asked to fill in the table. And you notice in the table that we're given the various x values, and we're supposed to be filling in our y values. Basically, what that means then is that we're going to take whatever the given x value is for a given row. So like I'm going to be looking at this first row here, where I see that x is -3. I'm going to plug that in for x in my original equation. So I'm going to go y equals the -3 times whatever x is minus 8. And so in the case of this first one, that's going to be a -3 in there. And then it's a matter of actually just going through and doing that math there. So -3 times -3 is a +9. So it's going to be 9 minus 8. And therefore, y here equals 1. And so my answer for that first box would be 1. And we're going to repeat that exact same process for each of the other rows. So let's do one more here together just so we can see the general idea one more time. So for this next one, we're going to go y equals -3 times whatever x is minus 8. In this case, x is -2. So then it's going to be y equals -3 times -2 is 6. And then that's minus 8. Therefore, y here equals -2. And so there y would be -2, and that's what I would put in. And I'm just going to repeat the exact same process going all the way down. One thing to put on your radar as you do this is that as you do, I hope that you will eventually start noticing a pattern that you can follow about how are the y values changing. And then see why is that pattern what it is given the original equation, because there is a connection between them that we'll be delving into in much more detail later, but I at least want you to be noticing it right now. Our next problem. In this case, we're not given an equation, but we are given the table. And from that table, we're going to be plotting points. And so basically, our table represents just a series of points. Every row is 1 point. So for instance, this first row in our table here is actually the coordinate pair -4, -10. And remember, the x's are going sideways and the y's are going up and down. And so when I see the point -4, -10, that's telling me to go left 4 and then down 10 in order to be able to get to that point. And remember, it is a single point. It's not two separate points, one at 4 and one at 10. No, it's 1 point. So I'm going to go left 4 and then down 10 and plot that point right there. And all we're doing in this one, you notice, is plotting the points. We're not going to try to worry about drawing the curve or anything through the points. And so then I go to the next row in my table, which is at -3, -7, and I'm going to plot that point. So I go to -3, -7, and plot it. And then we go to the next one, which is -2, -4, and I plot that point. And we just keep plotting each of the points from our table here down into our graph. And once we've plotted all of them from the table, we're done. That's all you need to do for this particular problem. In our next problem, this time we're given the equation and we're going straight to the graph. Now, there is a way that you can go straight from the equation to the graph. And if you remember how to do that, then by all means, do so. However, if you don't, remember what we just did on the previous two problems. In the first problem, we went from the equation into a table. And then we went from that table into the graph. We can actually do the exact same thing here. And so we're going to go ahead and, since I'm using the table here, I'm just going to start grabbing some x values. And you can actually choose basically any x values you want. A lot of people like to start at 0 for the x, and that is a great place to start. If I plug 0 into my equation up here, 4 times 0 is 0, and 0 minus 9 is -9. So then I go to -9 for my y. So notice that gave me a point. And I'm just going to keep doing this in my table. So like if x is 1, 4 times 1 is 4, because I'm plugging the 1 in here for x. And then 4 minus 9 is -5. And I can go ahead and just keep filling in the table the exact same way. But you'll notice that as I continue making my table, eventually I end up with something like this, where my y value is 11 here. That's beyond 10. Notice my graphing grid only goes up to 10. It doesn't go out to 11. And so once I hit a point like that I'm not going to be able to plot because it's too big, then I know that I'm not going to actually have to worry about plotting that point. So I can go ahead and just ignore that for the time being. Now, I do want to make sure that I have anything going the other direction as well, though. So remember, I started up here at 0. Well, I should also consider, what if x is -1? And if I plug -1 in for x, then 4 times -1 is -4, minus 9 is -13. That one happens to also be off my graphing grid. And so for that reason, I will also ignore it. But notice I did have to go and check it. You have to keep going in both directions until your y value gets off the graphing grid. So in this case then, we have a grand total of 5 different points that we're going to plot on our graphing grid. And yes, these are the only points we need to plot. We don't need to worry about the line or the curve that goes through them. We don't need to worry about decimals. This problem, we only are plotting the points, and that's assuming plotting the points that actually appear at the nice grid line intersections. And so if I plot each of those points the same way that I did it on that last problem, then I'm now done. And again, though, I will remind you again, if you felt like you could graph this one without having to make that table, by all means, yes, you are welcome to do so. That is something we will be talking about later, though. I'm just working on building a little bit of foundation in the meantime. Let's do one more like that one. And so notice again, we're given an equation, and we're supposed to plot the points on the graphing grid. So once again, I'm going to go ahead and think about it in terms of making a table of values. And so I'm again going to just start at x being 0, just as an arbitrary choice, in which case y is -7. And then I could go to x being 1, which will give me -10. And then if x is 2, then y is -13. Notice at this point, I've now just gone off the graphing grid. So that tells me I've hit my limit going that direction. So I started at 0 and I went up. Now I need to go down from 0. So what if x is -1? We need to check that as well. In that case, y would be -4. And we can again keep going down with our x's until we find one that is actually going to be off the graphing grid. And so we end up with all of these different points. Now notice -6, that ended up giving us one off the graphing grid, and therefore I don't need to worry about that one. And so then I'm going to be plotting each of those points that fit on my graphing grid, and that's all I'm going to have to do there. And so then once I plot each of those points from my table, I'm done. I have now successfully plotted the points from this particular equation.